Um, so I'm thinking that we might have a little bit of time left at the end of the hour for you to work and be able to get help. You'll most likely need it now that we're going to be working on full problems. And it's not that they're that difficult. It's just that there's a lot of details within these problems, and you guys most likely might get stuck on something or other and want to get help on it. So I guess the first thing I wanted to bring up. Uh-oh. This isn't a good start. It's only half working. There we go. Okay, I only put this box up here kind of for one reason, is that in the notes you're going to see that the no given and the find is going to be written in every box. And they are a good general guideline. It's not something that it's set in stone that you have to fill that information out. It's just kind of meant as a guide to help you guys navigate your way through all of the information in a problem. So that'll be written down for most of the word problems, but it's not like you have to fill them out. Like on a test, on the AP test, I'm not going to be asking you for no, given, and find. Like, you're welcome to write them down on your own, but you don't have to. Okay, so we'll start with this one, which isn't it isn't a full word problem. It's just kind of like a half related rate problem, because you don't know what the equations stand for. Or they don't stand for anything in particular. So it says, suppose x and y are both differentiable functions of t and are related by the equation y equals x squared minus 3x. Find dy dt when x is 3, given that dx dt equals 2 when x is 3. Now, for most students, the first time reading through one of these, it just feels like an overload of information. And I fully get it. So let's just start with this and kind of focus on it. Yesterday, we purposely were doing the derivatives of all these different equations. So why don't we start by doing that with this one? So we're going to take the derivative with respect to time. And it doesn't necessarily, it does say it up here, I guess. It says they're both differential functions of t. But otherwise, normally, all of our problems are going to be in time just because of the way word problems are. Apurva, you were the last one here today. So you're first up. Can you help me do the derivative? Like that? Yeah. Oh, that does remind me. I basically found out during fifth hour that I am the only person that writes the notation like this. Is pretty much every single person in here just writing y prime? Oh, okay. So in that class, there literally wasn't a single person writing the notation like this. I'm okay with you guys using y prime. Part of the reason I don't write y prime is because, to me, you don't know if that stands for dy dx or dy dt. I mean, they both mean the derivative of y, but I partially use the notation on the bottom just so it's clearer. I'm not going to mark it wrong if you guys use prime. But anyway, back to what you answered. It was very close and almost perfect. But yes,
What is the AP test going to need?
they usually accept either. I'll clarify that before we get there, though. So Apurva, the only thing that was off slightly is x isn't like the main variable. So the derivative of x isn't just 1. So after each derivative of x, we would have to write x prime or dx dt. So you did each derivative correct. Yes, sir?
So if t was in the equation, then that would be just 1.
Correct. If t was in the equation some way or form, then dt is 1. I can't do it. It's bothering me. I don't like the prime. Okay, so this equation down here kind of represents how the variables we were working with and the derivative information works together, basically. And when we look up above, it directly says find dy dt. So our goal is that this should be the only thing left without a number in place of it. There should only be one variable thing left when we're done to be able to solve it. So it says when x is 3, well, that means I'm going to put a 3 in place of each x. I guess that's the only one. And then it says dx dt is 2. So in place of each dx dt, I'm going to put a 2. Every one of these problems, when we're working them, there should only be one variable information left at the end, because that's what we're solving for. It's not necessarily going to be alone on the side of the equation like this one. So we've got 2 times 3 times 2 minus 3 times 2. What is that? 6, 12, 6. Now this one doesn't have any kind of units, so we wouldn't need to put that information in there, otherwise we should. But as a general overview, all of these problems are going to deal with derivatives because they're all dealing with how fast things change. So that's kind of going to be your main thing. You're going to have a main equation you're working with. You're going to take the derivative of it, and then you're going to be able to fill in everything but what you're looking for. That's the only thing that's going to be the same on all of these. Everything else could be completely different. The equations could be different, the information given different, the style of information, that's really changes completely depending on the problem. Yes?
How would you signify that you plug in the x equals 3? You know how you do s prime of 3? How would you signify it except with a dy dt?
I didn't hear that.
How would you signify that you plugged in the x equals 3?
Oh, I just write 3 in place of x.
No, but you know how you have f prime of 3?
Yep.
So how would you kind of do it in this sense, dy dt?
I'm not sure I follow. How should you write it officially?
I guess, yeah.
I mean, just the way I put it right here is okay. Just by saying dy dt equals 6, that's kind of the same thing as having function notation. I think that's what you're asking? Otherwise, as we do more of these, if you're kind of unsure as to what you're still trying to ask away as we're going, maybe it would make more sense as we get to units and things like that. Okay, the concentric circle pebble problem. I don't know. It's like the example they use all the time. It's been on multiple AP tests. It's like in every single brand of textbook. I don't know what their deal with the infatuation with this is, but they kind of are. My guess is this is usually a good opener problem because a lot of you can envision it in your mind. So, think of calm water. When you drop something into calm water, it just kind of makes circles that go out from it. The weird thing about those circles, if you ever pay attention to them next time, is the circles go out at a constant rate. And that rate that it goes out never really changes. What kind of does change is the size that the wave just kind of gets smaller as it goes out. But it moves out at the same speed. And there's different things you can look at or observe, whatever. But a majority of the time for calc, what they do is they'll discuss like the area of the circle. So because these circles are moving out at the same speed, when the circle is very small, like in the first second of the circle, the area doesn't change an awful lot. Like maybe it's like 1 square foot or something. But if you picture this circle when it's 10 feet wide, moving an extra foot, having a 1 foot swath around a 10-foot circle would be a lot more area being added than at the very beginning. So the amount of area being added to the circle as it moves farther out is different depending on where the radius is at. So that's kind of how calc works, is you look at different things that are changing. And I didn't even read through this one, but I'm almost guaranteeing that's what it is. A pebble dropped into a calm pond, causing ripples in the form of concentric circles. The radius r of the outer ripple is increasing at a constant rate of 1 foot per second. When the radius is 4 feet, at what rate is the total area A of the disturbed water changing? So it's pretty much exactly the question I thought it'd be. And like I said, it's pretty much the same in every different textbook and every different. It's set up the same because it's a good starter problem because a lot of you can visualize it. Now, to me, the know and the given, not that they're confusing, but to me, these kind of feel like the same thing. I can tell you, because a lot of you guys like using the answer key, like a lot of you study it and try to figure out things from it. The know is going to be like the main focus of the problem. So this particular problem, the main focus is talking about the area of a circle. So you're not directly given that, but we know that the area of a circle is pi r squared. So that's what you're supposed to put in the know if you're trying to pair up your work with an answer key. The given is going to be the information that's written in the problem. And looking through this one, we've got that. We've got that. And then we are asked to find that. So 1 foot per second. What does that stand for? So this is kind of what we were working on yesterday at the beginning of the hour. What is the 1 foot measuring, I guess, is kind of what you're supposed to look for. The radius. So the change in the radius compared to the change in time is 1 foot per second. So the foot in itself isn't necessarily going to directly tell you, like like in your head, you might think that's distance, which it is, but what you're actually measuring is the radius. So you're going to have to read through to kind of figure out what it stands for. This one says the radius is 4 feet. Well, that's just directly the radius. It's not a change, like it's not being compared to time. So it's just the radius is 4 feet. And then we're being asked to find what rate of area. So we're being asked to find dA dt, because the word rate represents derivative. Apoorva, can you call the next person? Cassie. How come she gets punished for you coming late? Okay, Cassie. What are we going to take the derivative of? Because that's kind of what we're doing with these problems. I see information dealing with derivatives, so I need to take a derivative. We only have one equation up there, so I mean that's usually a good indicator. Yep, the only one, yep. Do you want to call on somebody else to take the derivative, or do you want to do it? Okay, then pass that on to someone else, please. Hi, can you do the derivative of the area formula?
It would be 5 times 2r times dr dt.
Very close. You did it excellent. But you 100% forgot half of the equation.
Good to know.
The left-hand side.
Oh, yeah, that's right. dA
Yeah.
dt.
Yep. And I know it's super easy to focus on the right because that's where a lot of the main information is. Morning. Okay, so here's our derivative equation. And then if everything is set up right and if we have everything ready to go, we should be able to replace everything but one. dA dt is what we're looking for, so this should be the only thing remaining. So I should have pi times 2 times 4 feet times 1 foot per second. And I know I went through that quick. Are you guys okay with how I replaced everything? Okay. Otherwise, feel free to ask along the way. If there's something you're finding confusing that I might have skipped over or might have assumed you knew, ask away. What do we have? 8 pi? So we've got 8 pi feet squared per second. So when the radius is 4 feet, that's how fast the area is changing every second. I don't know. Is there anything about these that you might want to ask about? Yeah, go ahead.
How did you get feet squared?
The feet times the feet. No, that's fine. That's kind of why I like to write the labels in these, because then even if you're unsure what the answer is supposed to be labeled as, that kind of helps you figure it out. Because there's just an awful lot of details in these. I mean, like, it's hard to argue. Should we move on to the next one? Is there something about this one you want me to talk about? I figured I would try to take a lot of time in this first example. Okay? Now, obviously, balloons aren't actual spheres. It's just the idea. Because a lot of you can picture a balloon losing air or gaining air. So air is being pumped into a spherical balloon at a rate of 800 cubic centimeters per minute. How fast is the radius of the balloon changing? At the instant, the radius is 30 centimeters. Hannah, can you choose somebody on that side of the room so that we don't just immediately go through every single person right over here? Wow, that's cruel.
She told me.
I'm not sure Tyler even knows what we're working on right now. Or did you have a chance to try some of these yet? Okay, that's kind of what I thought. Should we go with, we should go with Caden. This will make up for all the other times he came in late. Wait, what am I talking about? Grace.
I didn't really do it.
Today you did, yes.
And yesterday.
Yes.
So,
This is your reform? Your reform, because you don't want to get called on, I see. Okay, Caden. Can you guide us? The beginning, the no is supposed to be, what is the kind of main topic of the problem? It's a sphere, okay, we'll go with that.
So we're trying to find the
Yep.
radius, right?
Oh, you don't even have to worry about the details of what we're actually trying to find. So we're working with a sphere right now. What kind of formulas do we know about a sphere?
The area?
Nope. You're right in tension, but no, not area. Volume?
Yeah, volume.
Yep. So we technically could find surface area of a sphere, but I don't think you're going to run into that one. So this one's going to be the volume of a sphere, and the 800 cubic centimeters that we saw listed would kind of be our clue that it's volume. So volume of a sphere, if you don't remember it, is 4/3 pi r cubed. And it's not super hard to just Google it if you don't remember it. Okay, good. Caden, you want to choose the next person? Who should be Grace?
All right, Grace.
There we go, since she thought she was going to, like, pretend that she didn't come late for, like, 6 weeks in a row. What information are we given?
it's a rate of 800.
Okay, good. What do we label that as, though? So the numbers is usually the easy part to find. What is that describing? Okay, how come R?
The radius.
Just throwing that one out there?
Yeah, I just know.
No, that's fine. That's why I'm trying to do these. So cubic centimeters usually measures volume. So it's the volume of the sphere is changing. Grace, do you want to pass it on to somebody else?
Sure.
Okay.
Maddie?
Oh, okay. I guess I should have guessed. Maddie, there's one other number in the problem.
30 centimeters.
Okay. And then that represents what?
The radius.
Perfect. Sometimes the numbers and the information you're given are like semi-obvious, like this one just directly says radius is 30 centimeters. Sometimes it's not. So like the 800 cubic centimeters doesn't really have wording that directly says it, so you kind of have to infer it by the labeling and the sentence. Okay, so good, we've got that. Maddie, somebody else?
Luke.
Which Luke? Okay. What are we being asked to find?
We're trying to find how fast the radius is changing, which is the derivative of the radius.
Perfect.
dr dt.
dr dt. So how fast, the word changing, I mean, like there's all sorts of different words that represent the derivative. And this one's the derivative of the radius. Okay, good. Do you guys think you could try the rest of it on your own? So take the derivative of the formula we have, plug in information to find the remaining item. This isn't going to be a great answer, is it? What is 8 over 36? 4 over 18? 2/9? I see an awful lot of calculator button pushing. So 4/3 times the 3 should be 4. 30 squared should be 900. 4 times 900, 3,600. So then the pi comes with it. 2 over 9 pi would be the best answer you could give. If you knew it was a calculator question, then obviously you wouldn't have to write the answer like this. But this is the answer that would be expected from you if you're not told to use a calculator. Like, obviously I don't know what that number's, off the top of my head, I don't know what that is. I guess it's 2 divided by roughly 30. So like 1/15th. So what is that, like 0.07? Okay, so it'd be close to 0.07 centimeters per minute that it's changing. That's actually really slow. I mean, you would blow a lot faster than that, just blowing it up with your mouth instead of a pump. I suppose that's because it's cubic centimeters per minute. And a minute is quite a long time for actually 800 cubic centimeters isn't a lot. How many of you ended up getting it correct? Just kind of curious. And if you got it wrong, that's fine, but okay. Is there a certain part where you went wrong? Was it just working with the numbers?
How did you get 3,600?
So I did 4/3 times the 3, and that gave me 4. And then 4 times 30 squared. 30 squared is 900. So 4 times 900 is 3,600. And then the pi would be 3,600 pi. So all of the numbers on the left were 3,600 pi. Or, excuse me, on the right. And then I just took the number on the left divided by 3,600 pi. And then I kind of just reduced it. Is there something about this one that, if you made an error, maybe you saw what you made the error on? I don't know. I certainly would be glad to help you on parts of this, because they're all going to look similar to this. So if you're making errors, you definitely want to kind of figure out where that's coming from. Should I do another one? Should I stop here and give you time to work? Another one? Sure. Okay, so different kind of shape. The answer key for this problem is slightly wrong too. So I had some people look at it yesterday and kind of ask me about it. There's some typos in the answer key. The top of a 25-foot ladder is sliding down a vertical wall at a constant rate of 3 feet per minute. When the top of the ladder is 7 feet from the ground, what is the rate of change of the distance between the bottom of the ladder and the wall? So I'm going to draw this one to help me out here. So there's the wall. There's the ground. There's my 25-foot ladder. And apparently the ladder is not changing size. And I'm guessing the ladder's too far away from the wall, so it's sliding down. So the top of that ladder is moving downwards. The bottom of that ladder is moving to the right. And that's kind of what we're working with. What kind of equation are we going to be using? So the shape is obviously triangle, because the ladder and the wall and the ground. What kind of equation do we know that works with the lengths of the sides of triangles?
X squared plus y squared equals.
Quit looking at the key.
What?
Are you looking at the key?
No, I'm looking at the thing we filled out yesterday.
Oh, perfect.
Are we not supposed
No, you absolutely can use that. I totally forgot that was even on there.
to? Oh, okay.
Yeah, we can even use X and Y. But Pythagorean theorem, that's what we're trying to work with. And you could call it A or B, you can call it X or Y. X and Y actually works easier for most people because then they can kind of picture an axis. And then that's going to equal 25 squared. This is where the error on the answer key is.
Oh, that's not on the sheet either.
No, where's the binder? Oh, I guess I have it over here. If you guys look up the answer key that I've posted in Schoology, this just says 25 on accident. That's the only thing I wanted to let you guys know. Okay, so we've got x squared plus y squared equals 25 squared. So Pythagorean theorem. What are we given? Jack?
It's moving down at a constant rate of 3 feet per minute.
Okay, how do we write that?
I don't know.
Oh, you are correct that it's moving down at 3 feet per minute. Oh, what did I miss?
What are you doing for attendance on Friday?
Just writing it down?
Are you doing Zoom?
Yeah,
We have to come on a Zoom and you're just gonna write it down?
yeah.
Okay. Right.
I think we could do it however we want, though.
Do we have to have a Zoom meeting on Friday? Am I interrupting you guys?
Yeah, but that's okay.
We should probably do it on Friday.
What?
I think maybe we should have on a Zoom meeting on Friday.
Just because-
You're not taking, I'm not taking cues from Sarge, no.
It's a good idea.
Why would you wanna have a Zoom meeting?
Exactly.
Yeah, 'cause I'm going to wake up early to like just log in and we're all just gonna be asleep anyway.
See, Sarge, what kind of ideas are you planting in their head?
I was thinking.
I just wanna know if we have to have a Zoom or not.
I actually don't know.
Alright.
I have no idea.
Wait, I have a question about. the-
I'm having a Zoom meeting.
I am as of right now.
And you have to have a camera on.
No, I know.
Yeah, I need to know you're there.
How do we get on?
Oh, really? Because last year, not that anybody didn't just log in and go to sleep.
I did that.
Yes.
I was the only one in the room
Oh my god, that always happened, like, everyone would like sign out and there's TV and the teacher, and they'd be like, you have questions? And they'd be asleep.
Can't imagine why I would want your camera on then.
I have a question.
Yes.
Because what the problem, is it always gonna be 25 even if the ladder's like not 25?
No. No, this number is only 25 because the ladder's 25.
Oh, okay.
That's why I didn't even put it together with that equation from yesterday.
Okay, it's on the equation from yesterday.
I'm sure that's why it was chosen for
Oh,
yesterday.
okay, got it.
Yeah, no, this is whatever number the ladder would be. Oh yeah, Jack, you were saying the down 3 feet, I think, right?
Yeah.
No, 7? 3 feet per minute. Can anybody help him out? Because it sounded like he wanted help with that. What does 3 feet per minute stand for?
So dy over dt?
Yep. So what is changing is the height. So if you know what, I didn't even label my triangle. I should have labeled it like that. That might have helped. The side of the triangle that's changing is y. Now, because the 3 is going downwards, it's -3. The y value is getting smaller 3 feet every minute. Okay? And then when the top of the ladder is 7 feet from the ground, so this is kind of at an instant, right? The 25 feet is always going to be 25 feet no matter what time you look at. But at a certain instant, when this is 7 feet from the ground, what would this length be? Correct. So sometimes you're going to be asked about some information that you don't know. Or you're going to be asked about some information that you're not directly given, but you would be given the information to figure it out. So we've got a 25-foot ladder, 7 foot. I'm pretty sure this is a Pythagorean triple, but I can't think of it in my head. Is it 7, 24, 25? Oh, it was?
24.
Okay. Usually these numbers that you're given are going to be pretty compatible. They don't have to be, but yes. So you use Pythagorean theorem to figure out this side, and it turns out to be 24 feet. So we know that y is 7 feet. We know that x is 24 feet. And then we're being asked to find what is the rate of change of the distance between the bottom of the ladder on the wall. So we're being asked to find how fast it's moving outward. Oh, God, I wrote a y. We're being asked to figure this out. Okay, should the answer be positive or negative when we're done? Should be positive, because the ladder is moving away from the wall. So the x value is getting bigger as the time goes up. Okay, so we've got x squared plus y squared equals 25 that we're going to take the derivative of. Should be 2x dx dt plus 2y dy dt equals 0. This is why it didn't matter that there was an error in the answer key, because doing the derivative, this should be 0 regardless. Does anybody know why this answer is 0?
Because it's a number, so. No.
I know you didn't mean that, but yes.
Is it because the length of the ladder isn't changing?
Perfect. So the ladder itself is never changing size. And so when you're looking at the derivative, you're looking at information that represents how much it's changing. Since the ladder won't be changing size, it's 0. And then we're just going to plug in the information we know, and then we are trying to find dx dt, so that should stay unfilled. So 2 times 24 feet dx dt plus 2 times 7 feet times dy dt, which is -3 feet per minute, equals 0. And then we got to solve that. So I am going to take the 14 times 3, 30, 42. I'm going to add that to the other side of the equation. that 42? 6? Yeah, 42. Uh, 7/8. Yeah. Oh, shoot, we're done at 21 today, aren't we? Yeah, it's Raptor Day. Actually, that worked out okay that we just did this problem and we were going to stop because we definitely wouldn't have been able to do another one. I would recommend you guys start the homework today. I mean, just work on it during Raptor time if you want. Get what you can done, and then tomorrow you'll kind of be able to come to class and then find out what you would have questions on. They're all set up different, so try to look at things in general terms. The only way that you're going to get good at these is by practicing different styles. It's kind of a downside to it.